Hey guys, Mr. Bicen here. I am very happy to do a live stream today. I'm actually going to do a mechanics live stream because I figured people have always been requesting for me to do lots more past papers, and I figured what better way to do some past papers rather than doing it in a live stream so people can ask questions as we're going as well. So I'm guessing you can all hear me. It'd be great if people could just say hi in the chat and tell me that everything is good before I sort of plow on with the rest of this session. Now, I don't know if anyone's looked at 2023 before, but Mechanics 2023, it might be one of the easiest mechanics papers that I've seen. I don't know if anybody's looked at this as part of their revision. But before we get started, I would love to know how your Easter holidays are going. Well, if they've already finished, I imagine you're probably back at school. Some people have still got them going, but I think most people have finished. And how are you feeling for the exams? I'm guessing we're all in year 13 here, kind of coming along to do some revision and some practice for some mechanics. So I would love to know how things are going for all of your studies, and to be honest, we will get started pretty soon. If you haven't seen, I've still been doing a lot of Turkish studying. I put a video up recently where I read out my first passage in Turkish, which I was really pleased with. It was fun. We've got some people that are stressed. Maisie, are feeling stressed. Honestly, if you are feeling stressed, that is a normal, like, healthy feeling to have right now. Being stressed is your body's way of saying that it's getting ready to do something. It's if it gets too much that you need to have a word with yourself and be like, what am I getting stressed over? Like, I know these exams feel like a really big deal. Your teachers and parents have probably been making you think these are like the biggest deal ever. I'm here to tell you, you're already doing amazingly by coming along to this live stream and doing all this revision. Everything is going to work out just okay. So everything's going to work out more than okay. Everything's going to work out brilliantly. So, like, no stress at all. And I see some people were there with me in the Easter break at the Aiming for a Star sessions. If anybody was in those sessions, I'd love to know what you thought of them. I've looked at all the reviews. I got some brilliant reviews. I think my average score is 4.86 out of 5. Basically, everyone was giving 5 out of 5 and gave me some amazing comments on those classes. So absolutely loved that. Yeah, and it's my favourite stream today, Karan. It is mechanics. I've especially worn the mechanics orange. All of my things are always in orange for mechanics for some reason. Okay, we are going to get started on this. Okay, we are going to get started. And just before I start, someone's just said, is it bad I don't feel stressed yet? No, just be grateful that you're not stressed. It's all good. It is all good. And yes, I will do some further mechanics streaming at some point. Yeah, and my coordination with my lamp and my jumper, of course. This is going to be all year 2 content of mechanics. So let's actually get started. Otherwise, I would just sit here for a full hour just absolutely waffling. But we're not going to do that. We are going to have a go at doing this paper. Now, this paper is the 2023 paper. So I am also going to be uploading this probably as just a past paper walkthrough as well. So that, I don't know, so that I've got a library of all of these past papers as well. Okay. Now, this paper, something I want you to always be aware of when you read the start of this paper. You know, when you're sat there in the exam hall and the exams officer's like, oh, make sure you read everything on the front. Do make sure that you are reading this piece of information, that all of your answers should be given to 2 or 3 significant figures, because sometimes you kind of stop this. Someone's saying, how did I get my iPad showing on my computer? I've bought a MacBook so I can live stream, just so I can live stream. This is how serious I'm getting about live streaming. I'm going to try and do a lot more in the build up to exams. So I've seen we've got a lot of people here. It'd be nice if we have lots of people in all of these live streams. Now, like I said, this paper is a pretty straightforward one. I'm not speed running this, but I am going to do my best at kind of getting through these questions nice and quickly with everybody understanding these things as well. So this one says that a car is initially at rest. The second I see initially at rest, I just jot down the fact that U must be equal to 0. It looks like it's going to be a SUVAT question, but I always want to write information down as soon as I get it. It then says that the car accelerates. Okay, definitely feels like it's going to be SUVAT, along the road with constant acceleration. There it is. The second we see constant acceleration, the proper name for the SUVAT formulae is actually the constant acceleration formulae, and we get that that constant acceleration is 3.2. It wants us to find the speed of the car, in other words, find out what v is after 5 seconds when t is equal to 5. Now, I know most people, when they do this, they start off by writing down SUVAT. I never recommend that, because when you have all of the letters there, it's hard to spot the formula. When you've just got the 4 letters that you're using, it's really easy to spot the formula. And obviously the formula that links these is V equals U plus AT. So V, the thing I'm looking for, is U plus A times by T. So we would just have 3.2 times 5, which obviously I could do without a calculator, what I haven't done. And it is 16 meters per second. I don't think you actually need to have the meters per second to get the mark, but there we go. Okay, so next part says find the distance traveled. So we know this time we're looking for what S is equal to by the car in the first 5 seconds. So we still know that U is 0, the acceleration is still 3.2, and we know that time is equal to 5. If you wanted to, you could use that V was 16, but it's probably not a good idea to do that just in case we got that wrong. So now I'll use the formula that connects those things, which is S equals UT plus a half AT squared. I honestly don't think I've ever seen such a start of a paper as like easy as this. Like it really feels incredibly simple for the first few marks that we've got here, okay? That is a really good idea. Someone's just said they're going to pause and do each one, and then when they finish, they can just watch me go through it. What an absolutely brilliant way to use the live stream. I've never even thought about doing it like that. That's such a great idea. And so that we get S is equal to 40 meters. And obviously at the end of this, I'll check the mark scheme to make sure I haven't made any crazy mistakes. I'm also checking the chat just in case I'm doing anything ridiculous, especially in one of these things that we've got here. Okay, so that was the first question. Look how much space they give you just to do that. It's ridiculous. And then they don't even give you a complicated forces question. This is crazy, okay? So it says here that a particle has mass 5 kilograms. The particle is pulled along a rough horizontal plane by a horizontal force of magnitude 28. I can see it here. I can see that it's rough because they've got this resistant force. The only resistance to motion is a frictional force of magnitude F newtons as shown in figure 1. I cannot believe this is a mark. Find the magnitude of the normal reaction of the plane on P. So I know there's a normal reaction force and I know there's the weight, which is 5g. So seriously, they are giving you a mark for saying that the normal reaction is 5g, which we know is 5 times 9.8, which is 49 newtons that we've got here. Like crazy. This session will probably be a little bit less than an hour. I can't imagine I'm going to spend that long kind of going through this paper, but if you want to at the end, I can answer some extra questions for you as well. So it says the particle is accelerating along the plane at 1.4 meters per second. Another easy part to the question, as soon as we've got acceleration and we've got some forces, we know we're going to be doing F equals ma. So we'll do F equals ma. And I always like to resolve it in the direction it's moving in. Not the direction it's accelerating in, but the direction that it's moving in as well. And I can see some people in the chat are calling out some people who have commented in a lot of my videos. That is Karan, who has commented in pretty much every further mechanics video. So, right, we're going to resolve these forces. So I have the resultant force is the 28 minus the friction. That's the thing that's going to go on the left-hand side. Obviously, the F that we have here is from the formula, not from the diagram, which makes it a bit awkward. And the mass is 5. And the acceleration is 1.4. So we're just going to solve this equation that 28 minus F is 5 times 1.4, which is 7. So 28 minus 7 is the force, which is 21 for the friction. So the friction is 21 newtons. I mean, this literally feels like year 12 maths. This feels like year 12 maths that we've got here, okay? So then we have, for the last part, it's a 1 marker. The coefficient of friction between P and the plane is mu. Find the value of mu. Okay, well, we've just found out that this frictional force is 21. And we know that the frictional force is equal to mu r. I mean, I've never seen such hand-holding throughout a question. So it's going to be mu multiplied by 49. So we'll just do 21 divided by 49. And it wants it to 2 significant figures. That's 0.43 to 2 significant figures for this question. What are we thinking so far? Like, are these not the easiest 2 opening questions you've ever seen of any A-level exam paper? That is great to see that, Jake, that you enjoyed the CP2 session. The further mechanics one, I've been planning the FP1 one today. Geez, I found some hard questions for that. And the further mechanics, if you come to the further mechanics session, trust me, you will finish that session just feeling, yeah, really, really up to speed with it. This is for sure like the easiest part of the paper. But sometimes we don't want them to be too easy, because if they're so easy and you make a silly mistake, you really feel like you've kind of fallen behind with some of that. Okay, so again, as soon as you see this question, tell me what the topic is. Tell me what's like screaming out to you when you see this topic, okay? That'll give me a chance to have a sip of my water and read what's going on in the chat as well. What is screaming out to us here? Yeah, this is always going to be available afterwards as well. So yeah, it's not going to be suvat. Obviously, it's vectors that we've got here, but it's like calculus with vectors. I think my favorite explanation was the person is.r42 wrote calculus with vectors and variable acceleration here. So I personally want to rewrite this so that I have v is equal to, I'm always obsessed with writing things as column vectors. And when we look at the mark scheme afterwards, I'll show you and prove to you that it can obviously be written in that form as well. So it says find the speed of p at time t equals 0. Now, when we see speed like that, we're obviously not talking about velocity. And so we know what that means. If we're looking for speed instead of velocity, we're going to have to use Pythagoras. I know that's what you were all thinking for us to do for this part here. T equals 0. I mean, could they make this question any easier, not even having to substitute anything difficult? So you just get 7 minus 3. Which means that the speed is just going to be the magnitude of this, the magnitude of v, which is just Pythagoras. So I'll do 7 squared and 3 squared. So that's the square root of 49 and 9. That's root 58. 2 or 3 significant figures for this. If I do 3 significant figures, that is 7.62 meters per second. Okay, the next part says find the value of t when it is moving parallel to ij. What does it mean when something is moving parallel to a vector? What does that mean when something is moving parallel to that vector that we've got there? And that will give me a chance to write this out and have a look at what's going on in the chat for this one. Yeah, good. Good. It does mean that the I component is equal to the j component. If you're not sure about this, you can just say that it's a multiple of the vector I plus j, and then it's going to be very obvious in a second that the I component is equal to the j component, because what we then have is that t squared minus 3t plus 7 is equal to k. Obviously, the I part here is equal to k. We then have that 2t squared minus 3 is equal to k. So in other words, this part is equal to this part. You didn't have to do that stuff with k if you spotted that straight away. To be honest, I tend to do it with k all the time just because it feels like the most sensible way of going about this, okay? So we've got a simple quadratic equation over here. I'll put it all onto the right-hand side. 2t squared minus t squared is just t squared. The minus 3t will go over and become a plus 3t. I'll do minus 3 minus 7, which is minus 10. And you know what? I've been doing FP1 today, so I think I can factorize this without using my calculator. We're going to get a t plus 5 and we're going to get a t minus 2, which means my solutions are either t is minus 5 or t is 2. But in the context of the question, it doesn't make sense to use a negative time, and I imagine it was probably stated somewhere over here that t was greater than or equal to 0 as well, okay? So I've been doing some very heavy maths today with conic sections and crazy things for further maths. I thought, you know what, I can factorize this myself. Now, what did we even want to do? It says find the value of t when it's moving parallel. Okay, simple. The value of t is 2. Part C of the question says find the acceleration at time t seconds. So I'm going to wait for a second. I want to look in the chat and you can tell me what to do to this part here to find out what we do for the acceleration. I want to find out what we do for the acceleration for this. And I will write something down over here that might help me. Yeah, we're going to differentiate, aren't we? Now, if you can't remember which one it is for differentiate or integrate, write down the letters of suvat, S-U-V-A-T in that order, but just the ones for S, V, and A. If you want to go down this list, we differentiate. Down goes with differentiate, and then obviously the opposite of that to go up the list is to integrate. So I'm just going to differentiate. I don't even really need to tell the examiner because it's obvious that I'm doing that in this next step. When I differentiate with respect to t, I just get 2t minus 3. And then for this part here, I just get 2t squared goes to 4t. Now, it does say here, find the acceleration of p at time t seconds. So I'm just going to leave it in that form that we've got there. If I wanted to, I could put in some units. If you really wanted to, you could write it as 2t minus 3i plus 4tj meters per second squared, but I'll show you later that you can always write it in column vector form. So I'm going to leave this off because I don't think this is very necessary for us at all. And then for that last part of the question, for part D that we've got here, it says find the value of t when the direction of the acceleration is perpendicular to I. So if it's perpendicular to I and we're talking about the direction of the acceleration, it's moving parallel to what? If something is moving perpendicular to I, what direction is it actually going to be moving in for this? Yeah, Eunice, I probably will only be able to do the 2024 papers after they've been unlocked, and then I can actually go through the papers because I sat those as well. So yeah, it means it's either going in the J direction or the negative J direction. We'll just presume it's going in the J direction for now, but in a second we'll be able to figure out what's going on. So it's in some multiple of the J direction, which is 0, 1. So in other words, 2t minus 3 and 4t is just equal to 0 and k. So I think it makes most sense to have a look at the I part. So 2t minus 3 is equal to 0. 2t is 3. And so t is 1.5 seconds. I mean, it just seems crazy. Like, first three questions, if you know what you're doing, it's a walk in the park. Sometimes you know what you're doing, but it's really challenging as well. So I think this one feels like kind of a quite simple one. Someone's asked me, when are my Turkish videos going to come out, my maths Turkish videos? I have to tell you what, I've got a hell of a lot more Turkish to learn. I had a Turkish lesson this morning, which was crazy. During the lesson, the earthquake, I don't know if you've seen in the news, but there was an earthquake in Istanbul today. My Turkish tutor lives in Izmir, and even in Izmir, they felt the earthquake happen. And my Turkish tutor, very unfortunately, was in the 2023 earthquake, and she lost her home in that earthquake. So she was very scared when it happened, but moments later, she was like, it's all good. So yeah, there was the earthquake today. Earthquake in Turkish is deprem. Deprem. So there was an earthquake today, but from what I've seen in the news so far, everything seems okay. My family were okay, but it's quite scary for that to be happening there. Anyway, this is always what happens when I'm doing a live stream. Whatever I see going on in the chat, I always get so distracted with these things. Okay, let's try and identify the topic. As soon as you can identify the topic in mechanics, easy peasy. Everything just kind of like flows from there. So a particle is moving on a smooth horizontal plane. Ooh, here we go. Massive key phrase for us that we've got there. And as soon as I see that, I'm just going to write it down. It says that the particle has constant acceleration of 2.41. Just write it down, and then I don't really need to read that again. It then says at time t equals 0, it passes through the point A. At time t equals 5, it passes through B. The velocity of P as it passes through A is minus 16 minus 3. So what do you think the letter is going to be for that minus 16 minus 3 that we've got here? What do you think that bit's going to be? Yeah, it's just U, right? It's the initial velocity that we've got here. And the big clue for this question was when we saw constant acceleration, that is your signal to go suva. As soon as you've got variable acceleration, you go, okay, that's calculus. If it ever said constant speed, it's like GCSE, distance equals speed times time kind of stuff. And so it then wants us to find the speed, so there's that keyword speed, as it passes through B. Well, it passes through B 5 seconds later, so t is equal to 5. Obviously, I could have written these things as a list if I wanted to as well, but it doesn't really matter. And what does it want us to do? Find the speed. So I want to try and find out what v is equal to. So we know that v equals u plus at. It's just standard kind of stuff here. That's minus 16 minus 3. And the acceleration is 2.41, and that's getting multiplied by 5. So for the top part, it will be minus 16 plus 2.4 times 5. Which is minus 4. And then for the bottom part, it will be minus 3 plus 5, which is 2. But it did say speed, so that for some bizarre reason they are testing the same skill twice in the same paper. We do Pythagoras to that thing. So that's the square root of 20, which is 2 root 5, but because it's mechanics, we'll do it to 3 significant figures, which is 4.47 meters per second. I mean, just seems kind of like crazy to me how simple this paper has been so far. Testing again the speed that they've got there. Good afternoon to Jawad, just looking in the chat and seeing what people are saying as well. This is the 2023 paper. Okay, then we get told the position vector of A, that's where it starts, okay? So as soon as I see this was where it started, does anybody remember what letter I used to represent the position vector of where it actually started? Very good. This is the R0 that we've got here, the initial one. And I do that because I like to use that in my my formula that I use for this. So we now have that R0, where it started, is 44 and minus 10. And what else does it say? At time t equals t seconds, P passes through the point C. the position vector is 4 and c. So this means where it gets to is 4 and c, and we're saying that the time is t. Now we've got all of these values. We've got u, we have got a, we have got r0, we have got r, we have got t. What is the formula that kind of adds or puts all of these things together using those letters? And again, this is just where like memorizing stuff can make you feel at an advantage. And I know this is probably going to take people a while to type this one out, but it's obviously one of the Suvat formula. And for vectors, we have a slight variation on this if we're not talking about displacement, if we're trying to talk about where it is. Now to Lord of Demise, who'd said R0 equals R plus T, I think that might be that, and Mariam as well, I think you're thinking of where there is no acceleration. I'm wanting to think of the version where there is acceleration. Good, it's the variation of S equals UT plus a half AT squared. In vector form, it's R equals R0 plus UT plus a half AT squared. Okay, that's the non-vector form. This is the vector form. If there is no R0, then this R is the displacement. If there is an R0, this is the position. Okay, because obviously if there was no R0, we're just saying how much has it displaced. If there is R0 and we're adding on to where it started, that tells us where it finishes up. So now that you know now you know all of these things, we can sub them in. So this is where it is. This is where it started. We then have u multiplied by t. So this is from earlier on. This is minus 16 minus 3. Minus 16 minus 3. That's being multiplied by t. And then we have a half times the acceleration times t squared. So this is going to be a half times the acceleration, which was 2.4 and 1. And then t squared. And for some reason, I've not positioned it very well, so I'll put it down here. And then it's just literally a case of going through and solving this equation really carefully. So we have the 4c, the 44 and the minus 10. For the next part, we're going to get the minus 16t and the minus 3t. And I'll do this all in one go. Half of 2.4 is 1.2, and a half of 1 is 0.5, like this. So I think it makes sense to have a look at the I component, because that's where we have the most information. So 4 is 44 minus 16t plus 1.2t squared. So as a quadratic, that's 1.2t squared minus 16t plus 40. And again, we can just whack that on the calculator, because this isn't pure math, this is mechanics. So they should just be allowing us to use this. And we get these two values. You get that t is equal to 10 or t is equal to 3.33. But I'm wondering if we spotted this in the question. I didn't kind of make a big deal of this, but it does say that t is greater than 5. Okay, so t is actually greater than 5. So I'm going to reject that one. I'm going to say that t is 10 seconds. Okay, we're on to the last part of this question. I've said it's D, but it's actually part C, which is just to find the value of C for this question. So let's get rid of this, and we're going to find out what C is. We're just going to finish off what we started. So I'm now going to look at the bottom part of this, and I will say that C is minus 10 minus 3t plus 0.5t squared. And remember, t is equal to 10, so I can just substitute that in that we've got there. Okay, so C is minus 10 minus 3 times 10, which is 30, plus 0.5 times t squared, which is 100. So you could put in your calculator, but you get that C is equal to 10. And I don't know, do you ever get this feeling, like, you know, when the previous answer was t equals 10, and then you've got C equals 10, something like that kind of just makes me feel like a bit uneasy. Do you know what I mean? When you get like an answer that comes up twice, kind of makes me feel a bit uneasy. Don't know if anyone's ever felt like that with that kind of stuff as well. But everything seems pretty smooth so far for this paper. We obviously need to check the marks at the end to see if we've got this one. I'm not even really going to ask you about what this topic is. It should feel incredibly obvious what this topic is. I say I'm not going to ask you. I'm obviously looking in the chat as well to see if anybody is going to tell me what it is. But it's so blindingly obvious what this question is because of the shape of the graph, or the shape of the diagram, because of this word projected that we've got here. The thing I find strange about this is like half of the page is this diagram. Like, it's so ridiculously huge the way that they've drawn it. Anyway. So it says, we know how we do these questions, right? We consider the horizontal and we do the vertical, we kind of consider them separately, and we think of one value that links between them. What is the value that links between these two things that we have, between the horizontal motion and the vertical motion? There is, yeah, it's t. It's the time is the bridging value that I often say for this kind of thing. So I'm going to add some stuff onto the diagram before I even read the question. That's going to be my 28 sine alpha because it's obviously opposite the angle, and this is going to be my 28 cos alpha. We remember that for horizontal, the speed is constant, and of course we remember for vertical there is minus 9 point, well not minus 9.0, I'm going to say there's downward acceleration of 9.8 because of gravity that we've got there. So it's been projected with this speed 28 meters per second on horizontal ground. After moving for t seconds, it passes through the point A that we've got here. The point A is 40 meters horizontally and 20 meters vertically from the point O, as shown in figure 2. The motion of the ball is modelled as that of the particle moving freely under gravity. Given that the ball is projected at an angle alpha to the ground, use the model to show this thing for only 2 marks. They're really going to hold our hand through this. Now, I think I'm probably just going to do the horizontal one because it's only 2 marks. It kind of feels like this might be one of the more simple ways to approach this. So I'm going to do horizontal motion. And of course, when we do horizontal motion, because the speed is constant, I'm just going to use my very GCSE formula that distance equals speed multiplied by time. I don't like doing suvat for when the acceleration is 0. Okay, so we know that the time they've said is t seconds. We've just said that the speed that we have is 28 cos alpha, and the distance that it's moving horizontally is 40 meters that we can see in the diagram, okay? So we will go in here. It's going to be 40 meters. So putting that all together, 40 equals 20 cos alpha multiplied by time. So 40 over 28 cos alpha is time. The only thing that needs doing here is the 40 and the 28 can simplify. So 40 over 28 is 10 over 7, which means that t is 10 over 7 cos alpha for this part. Yeah, someone said in the chat, for the horizontal, the distance is always equal to speed times time because the distance is always constant, meaning there is no acceleration for this. And then it then asks us to show something that I agree probably looks quite unusual, but there's obviously a piece of information that we haven't used yet, which is this vertical motion with this 28 sine alpha that we've got here. So we're going to be considering with the acceleration downwards. I personally am going to consider upwards as my positive direction in this question, but it doesn't matter if you do it the other way around, you'll still end up with the same thing here. So I'm going to do vertical motion. I'm going to do upwards as my positive direction. It was projected upwards with speed 28 sine alpha. Vertically, it displaces 20 meters. It starts at the bottom and it goes 20 meters higher up like this. We've just said that t, capital T, we've worked out is 10 over 7 cos alpha, because that's the value that connects these things together. And what else do I know about? Oh yeah, of course, the acceleration is minus 9.8. So now I've got these things connected together. That should be a lowercase t, shouldn't it? I've got those 4 letters. That is S equals ut plus a half at squared. When you do projectiles questions, you'll find that S equals ut plus a half at squared is definitely the most common one that you come across. So S is 20. We then have 28 sine alpha multiplied by t, which is 10 over 7 cos alpha. We then get a half of the acceleration, which is minus 4.9, and that's all going to get multiplied by t squared. So that's going to be 100 over, careful when you square this, the 7 squared is 49, and then you get cos squared alpha. So let's just do a little bit of tidying up to see what's going on here. So I have the 28 times the 10. I have the 28 times the 10 divided by the 7. 28 times 10 divided by 7 is 40. So I get 40, and then I have the sine alpha over cos alpha. And we know that sine alpha over cos alpha is tan alpha. And then again, if I just deal with the number parts of this one, I have the 4.9, the 100, and the 49. 4.9 times 100 divided by 49 is just 10. So I get minus 10 over cos squared alpha. And we're getting pretty close to what's been going on in this question, because we've definitely got something to do with tan. I think I need to figure out the extra tan squared part that we've got here. How am I going to get tan squared? So this is where looking at what you're aiming for can often be a really smart way of thinking, okay, what next? Right, well, I've got a tan alpha. This is the problem that we've got here. Any suggestions of what I can do with this cos squared alpha? I'm going to give you the first part of the suggestion, and then I'm going to have a look at the chat for this. This is going to get rewritten. I'm going to write it as a sec squared alpha like this. And then what's the point of that? Why is it good to write it as sec squared alpha? And this is something I please want to make sure you have all got memorized. And there we are. The first person in with this was coding with Ronak. And we can use the identity that sec squared is 1 plus tan squared. And then suddenly the equation is all in terms of tan. So sec squared is 1 plus tan squared alpha. I'd love to know in the chat who actually follows, who has memorized that, because it's such an important one to memorize that allows you to see stuff like this really easily. So putting it all on one side, I get 10 tan squared alpha minus 40 tan alpha plus 30 equals 0. Divide everything by 10. And we came up with what they wanted. The more past papers you'll do, the more you see the same tricks coming up all the time. All the time. Yeah, good. Loads of people, well, lots of people knew what that was. People derive them from the standard ones. I'm telling you now, if you memorize them, you put yourself in a stronger position. I know so many people are like, oh, I just derived them. Just make sure it's just such a speed up kind of thing. Now, what does it feel quite strange here? Like, we've come up with an equation. What do we normally do when we get this equation? What feels like something that's like a sensible thing to do once you have this? I'll talk a bit at the end with some of those questions about like grade boundaries and things like that. Yeah, normally you're just going to solve an equation. That kind of feels like the whole point of what's going on here. So I think it's going to be sensible to solve this even before I've read the rest of the question. So it says, find the greatest possible height in meters of the ball above the ground as the ball moves from O to A. So this definitely feels like something to do with vertical motion, because we're talking about the height above the ground that we've got here. But I'm actually just going to solve the equation because it's like we've started the question. It's like I kind of want to finish it off. Now this is a quadratic. I call these pseudo quadratics, but this is a quadratic in tan. If you wanted to, you could let y equal tan alpha, so that you have y squared minus 4y plus 3 equals 0. You can factorize it. You can use the calculator. I don't mind how you want to do this. But you get y minus 3 and y minus 1. So either y is equal to 3 or y is equal to 1. So tan alpha is 3 and tan alpha is 1, which now means I can find out what alpha is equal to. It's going to be the inverse tan of 3, or it's going to be the inverse tan of 1. I'm not going to touch my calculator for this one, because I know that's 45 degrees. But this one I will touch my calculator for. I'll do the inverse tan of 3, and that is 71.565 degrees, blah, blah, blah. Okay, I'm just going to leave that on my calculator because I think I might need that in just a second. Now we're going to consider what it's about when we're asking for something to find the greatest possible height. When we talk about greatest possible height, what do we normally look for when we have that kind of stuff? I personally would do degrees for this just because it's mechanics kind of stuff, so I probably wouldn't do that in radians. We'll still give you the same answer. Yeah, we're going to go with v equals 0 for the vertical motion. So we're going to say for the vertical motion, we now do a quick bit of Suvat. We're going to say s is the thing I want to find out. V is 0. The initial was 28 sine alpha. And what else did we know about? Oh, of course, the acceleration is minus 9.8. And so the things that connect these together is v squared equals u squared plus 2as. And I'm going to be subbing in a couple of different values here. So let's just start off with the v is going to be 0. So it's 0 is equal to 28 sine alpha squared plus 2 times by the acceleration multiplied by s. We're trying to find out what s is equal to. So this is, just leave it as 28 sine alpha squared. And then 2 times 9.8 is 19.6. So when I rearrange this, s is going to be 28 sine alpha squared divided by 19.6. Now, you could probably have a guess. Which one of these angles do you think is going to get the ball to go as high as possible? Do you think it's going to be the 72 degrees or the 45 degrees? Which one do we think is going to get it as high as possible? Yeah, it is the larger angle. You can think of that practically when you throw something at a steep angle as opposed to something at a shallower angle that we've got here. You can think of it mathematically. Sine of 45 is smaller than the sine of 71.565, and we want this thing to be as big as possible. However, if you do test them both, which I would do if I was in the exam, so if alpha was 71.56, then we can literally just type it into our calculator. So I do the sine of the angle, times it by 28, square it, divide it by 19.6, and I get that S is exactly 36. If alpha is 45, let's find out what S is. So sine of 45, times it by 28, square it, divide it by 19.6. It's only 20, so I'm not going to use that one because I want it to be the maximum possible height. So it is 36 meters for this one that we've got here, okay? And what does it say here? So we found the greatest possible height. It then says the model does not include air resistance. State one other limitation of the model. Now, I would love to know what you think for this in the chat of what people would write down. I have one that I kind of would always go to at this point now. There's always something I would like to kind of suggest for these as well. It says it does not include air resistance. It says state one other limitation of the model. So we definitely can't say that. Okay, good. I'm seeing basically all the answers coming up. Adrian Wu says wind. Haven't taken wind into account. Golden says it's about a particle. We haven't taken like the dimensions of it into account. The spin on the ball. Rotational forces have been ignored. The dimensions of the ball have been ignored. But my favourite one is what Tom Morgan has said here, is the accurate value of gravity. Now I'm going to say here, a limitation is, I will say, G has G is not being used to an exact value. Also, G could be more accurate. 9.8 has been rounded, but there are plenty of different ones that we could say, and basically people have answered that really well in the chat. But a more accurate version of G is something that I always like to use in these questions. Okay, we're on to the last question, question 6. We've been a bit of time on this, but we'll easily get this finished now. And it says here, this one looks scary. I think this one looks kind of scary that we've got here. And we have got this thing that also looks scary in this question. But I tell you what, I'm just going to break it down and make it seem as simple as possible. So it says that the rod AB has mass M and length 2A. The rod has its end on rough horizontal ground and end B against a smooth vertical wall. It makes the angle theta with the ground as shown in figure 3. The rod is at rest in limiting equilibrium. Okay, so it's at limiting equilibrium, and I think later on in the question they're going to talk about it being uniform, but for now we'll just answer this beginning question. It says state the direction left or right on the figure 3 above of the frictional force acting on the rod at A. Give a reason for your answer. Well, I know there's going to be a normal reaction here. This beam that we've got that's like this, it's like this. And actually, I'm going to do it like, which way am I going to do it? So it's the opposite of what I'm seeing on there. It's like this kind of way, and it's wanting to slip like that. It's wanting to slip down. In other words, it's wanting to slip to the left, which means the friction must be going to the right. So in this question here, state the direction, we will say that it is going to the right because the rod would slip to the left. Do not do what I am doing here. Do not write this in the middle of the paper. In fact, I don't like that so much. I'm going to remove that and I'm going to pop it down here because we should not write things next to the question. We should write them down here so it makes it really easy for the examiner to see. Okay, it then says the magnitude of the normal reaction of the wall on the rod at B is S. So I now have that the normal reaction here is S, but I don't need a frictional force because it's on a smooth wall that we've got, okay? In an initial model, the rod is modelled as being uniform. Great. So I can now go back to this mass M and I can put it right in the middle and I can call it mg. And they told me that the length was 2a, which means I can now say that distance is a and that distance is a that we've got there. And there are no other forces that are required for this question. But because it's in limiting equilibrium, later on I know that this friction is going to be mu r that we've got there as well, okay? I like that suggestion of someone saying, using a pen and letting it act as like a ladder and like imagining literally like what happens if you rest the pen against something, it's going to slip like that. So the pen was going to move in one direction as well. No, this is definitely year 2 stuff. Seeing someone ask about this. Okay, by taking moments about A, I mean, I know it's not easy to take moments, but they're like literally telling you what to do in the question. I've never seen a paper that's like this. So we're going to take moments about A. The good thing about taking moments about A is that this force and this force can be ignored. Okay, those forces are going through A, so we don't need to use them. So I'm going to be concentrating on the mg force, and then afterwards I'll do the S force. So when you take a moment about A, we are going to be saying that the mg force is going to be multiplied by the perpendicular distance. So the perpendicular distance that we're looking for is this distance along the bottom. Now, I often like to redraw these triangles. So that triangle that I'm just talking about, A is the hypotenuse, and that's theta, and I'm looking for that distance. I do not label this as mg because this is not a force diagram. This is a distance diagram that's happening over here. And that distance is A cos theta. It's adjacent to the angle, so it's going to be cos theta for this one as well, okay? Yeah, people are saying if you do each force as a right angled triangle, you can do it in a different way. This has just always been the approach I've used in all of my videos, and it's how I show this to my students. So it's going to be A cos theta is the distance. And then for S, we're going to do S multiplied by its perpendicular distance. So this was with the mg. I'm going to do S in this kind of blue color like this. And we're going to find out the perpendicular distance from A, which is going to be this distance here to here. So I'm going to draw out this big triangle, that kind of shape that we've got, and we will use that to find out what the distance is. I want to find out that distance. I know this is 2A. I know this angle is theta because this angle is theta, and it's obviously like Z kind of angles or alternate angles for this, which means that this distance is 2A sine theta, because it's the opposite to the angle. So I'm just going to multiply the S by the 2A sine theta. So that is 2A sine theta. And so the S was the part I was just doing in blue, okay? This distance was the one I was doing in black. And this distance was the one that I was doing in green. So I can cancel on both sides. They both have A. So I get mg cos theta equals 2s sine theta. I'll divide by 2, so I have a half mg cos theta equals s sine theta, and I'll divide by sine theta. And when I do cos theta divided by sine theta, I get cot theta, which was the thing that they wanted us to prove. Now in these questions, there's always like a few things that we're expected to do in these questions. One of them is take moments. There are 2 more things. What are those 2 other things that we're expected to do? Resolve up and down. Good. I wanted to give people a bit of time to think about this. We're going to resolve vertically and we're going to resolve horizontally. Now I'm going to get thinking about this diagram. The ones that are going up and down, I have R being equal to mg. And then in the left and right direction, I have that S is equal to the friction. Okay, so I'm going to get rid of that from the diagram so it doesn't get too messy in the final saved form of this. But resolving up and down, R is mg. Resolving left and right, S is equal to the friction. And a typical me, I haven't even read the question yet, but that's because every single question is the same thing. Resolving up and down, R is equal to mg. Resolving left and right, S is equal to the friction. Now let's actually see what the question said. The coefficient of friction between the rod and the ground is mu. Given that tan theta is 3/4, find the value of mu. So I know this. I also know that tan theta is 3/4. Oh, okay, I tell you what. I'm going to just work on that as well. If tan theta is 3/4, cot theta is 4/3. So that means S is a half mg times 4/3. A half of 4/3 is 2/3. So S is 2/3 mg. And I know that R is equal to mg. And I know that friction is mu R. So S is equal to mu times by R, which we've just worked out is mg, which is mu mg. And now I've come down to this stage where I know that this thing is mu mg, and it's also 2/3 mg. So I can say that mu mg is 2/3 mg. Obviously the mg's cancel, and we just get that mu is equal to 2/3. And if you wanted to do it to 3 significant figures, 0.667 for this thing that we've got here, okay? So I think this question again is quite simple once you let yourself calm down from seeing things like a cot theta in one of these questions. It then says, and this is maybe a weird part of the question, find in terms of M and G the magnitude of the resultant force acting on the rod at A. So when we look at A, there are two forces that are acting on it. There's R and there's friction. We have these two forces. I can never know which way I'm going to come up in the camera. There's these two forces. We need to find out what's their like overall force, and we do that using Pythagoras, okay? So we've got R and the friction. So for part D of the question, I think it is. Yep. We've said that R is mg. The friction, we've actually already said, is S or mu mg, which is 2/3 mg. So we have R and the friction. If we are going to find out what this is as a resultant force, as like an overall force, we do Pythagoras with the friction and with the R that we've got there. And the way we do this is the overall force will be the square root of these things squared and added. Now I know there's going to be an mg there, so I'm actually just going to put the mg out the front, and then I'll do Pythagoras on the numbers. So that would be the 1 squared that goes with the 1 mg, and the 2/3 squared that goes with the 2/3 mg. So it's going to be mg multiplied by the square root of 1 plus 2/3 squared, which is root 13 over 3. Or if we did root 13 over 3 to 2 or 3 significant figures, it is 1.20 mg to 3 significant figures for this question. So kind of like a weird one for this one. And someone says, are we ever asked to find overall forces in a way that isn't a right angled triangle? No, it will always be a right angled triangle in this situation, okay? And then the very last part of this whole paper, and then we'll have a chance to go through some of the chat that we've got here. It says a new value for S. Oh, sorry, in a new model, let me start again. In a new model, the rod is modeled as being non-uniform with its center of mass closer to B than it is to A. A new value for S is calculated using this new model with tan theta equals 3/4. State whether the new value for S is larger, smaller, or equal to the value of S compared to using the initial model, and give a reason for your answer. So we just need to think how our calculations would be affected given that this mg is no longer in the middle, it's moving up closer to this part. Now, it's maybe the tricky part of the question, but what does that mean is going to happen? If mg is going further up the rod, it says closer to B. In our calculations, which one is that going to affect? Is it going to affect resolving up and down? I don't think so. Is it going to affect resolving left and right? I don't think so. So it's actually going to be affecting the moments equation. In other words, as this thing moves further away, this distance would be getting bigger. So this moment that's being created, that rotational moment, is going to be bigger in that clockwise direction, which means that S has to increase to counteract it, okay? So all I'm going to do for that last part, it said the new value of S is going to be larger. S will be larger because the moment created by mg will now be greater. Of course, you'd probably want to go back through the paper and check all of these things here. What I'm going to do is just quickly get myself ready with the mark scheme, and then we can just double check that we got everything correct in this paper here. Okay, so let's jump back to this. What do we think? I think this is a very simple one that we've got here. We'll double check that we've got this all correct. I hope I haven't made any mistakes. So we have got, if I just get the correct pen color for this, we got the 16 and we got the 40. Although it seems to have glitched. We got the 16 and the 40. Perfect. Here we got the 49, we got the 21 and the 0.43. In this question that we've got, we had the 7.62, which is here, t equals 2, which is here. We differentiated it and we came up with that expression, which is here, and we got that t was 1.5 for this part. For the next one, They wanted 4.5, which we have here, 4.47. We got that T was 10, which was here. And we got somewhere C is 10 that we have in this point, okay? Nearly there. Well, part A of this question was a show that, so that's fine. And that was also a show that here, so we knew that was correct. And then we got 36 meters for this part, so we knew that was correct. And they've said, yeah, G could be, it uses an inaccurate value of G, so we can get that mark as well for this too. And then for the last one, we knew this was correct because, well, this bit, I think we've got, it is right as the weight of the rod will mean the rod tends to slip to the left, so we would have got this mark too. This was a show that question. We got that mu was 2/3. And for the last part, we got the 1.2 mg, which is over here. And the new value of S would be larger because the moment would now be greater as well. So a nice 50 out of 50 for this. And we've still got 10 minutes to spare to go and check through some of these things that we've got. So I'm going to now switch back to this so I can just answer some of the questions. And we'll just do the last part of this live stream. So I just want to say thank you very much to Breezy, who does moderation on these things as well. Not much moderation is required because you're all very focused on these things. But if you come to any of my aiming for A-star sessions, you'll have seen Breezy, you'll have seen Karan, you'll have seen Awan, you might have seen Ali. I don't know if any of these guys are in there. I know Karan and Breezy are in the chat as well. Okay, so I am going to just do maybe like 5 minutes of just looking through some of the chat that we've got here. Someone says, at the moment, I hate moments. Just go to my, it's called Rigid Bodies. I think the part 2 section of that playlist, just watch loads of those questions. It is just going to make so much more sense for that kind of stuff. I am going to keep doing these. Like, if people like these live streams, I mean, I've had like 150 people watching it. It's so much fun for me to do these things. I will continue doing them. I think I'm probably going to stick with doing like past papers, because then afterwards there'll be like a library of like all of me going through all of the past papers as well. Okay, someone says, do I reckon hinges will be asked this year? Not really. I mean, yes, they could be. But it just feels like the recent years, it's like things have been getting more and more like simplified and predictable. Hinges would be the same kind of diagram as this one, which I know you can't see anymore, but it'd still be like the X, Y. We had the R and the friction. It would just be with X and Y instead. So it doesn't feel like it should be that challenging for this as well. Maybe when there's a new Zelda game, I'll be doing start to become a Twitcher rather than just a YouTuber as well. Which is my favorite out of pure mechanics and statistics. I love mechanics. I don't know if you've watched my videos, you will know how much I love mechanics. My favorite thing about mechanics is students saying to me, I don't like mechanics, I don't like physics. And then by the end of their time of studying with me, they're like, you know what? I actually really do like mechanics. I used to like that a lot when I would get the students in year 13. They hated mechanics in year 12. And I was like, right, here we go. Let's make sure that you're a mechanics convert that we've got there. I don't think that there will be lifts. Honestly, my predictions this year is that things at the moment in 2023 and 2024, they've been kind of stabilizing with very high grade boundaries, but the papers are definitely more accessible. And there is a document. I don't know if someone might be able to send this in the chat, or maybe I can actually send this in the chat as well. There is a document where basically they've reviewed what is going on over the last few years, the last 2 years, and they're really happy. Edexcel this is, they are really happy with like the improvements that they've made to the papers to make them like easier. They're not easier necessarily, but they are more accessible. In this document that I've just sent you, they've basically just been saying stuff like, yeah, we're really happy with how we've done this. We have made the papers more accessible, so it makes it feel like it's going to continue going that way, which means I think there is going to be the same grade boundaries, if not higher grade boundaries as well that we've got there. Yeah, I kind of agree with you, Ash, that lots of the problem solving is now just like they spell it out for you, like part A, B, C, D, that kind of stuff. But it should mean that it feels a bit easier in the 2023, 2024, 2025 sort of like era of exams. Of course, they can change anything they want at any time that they want. There's probably just a handful of examiners writing these papers. If they just decide they're wanting to make it a bit trickier, they'll make it a bit trickier. Okay, they'll make it a bit trickier, and it will get reflected in the grade boundaries going down if it gets harder. So we have to be prepared for anything, which is why if you want to be prepared for some of the more challenging kind of stuff, I know loads of you have been to my aiming for A-star sessions and stuff anyway, but those ones really do try and cover like the most challenging things. This was a slightly easier paper, but if I go through all of the other ones, we'll come across some tricky ones as well. Okay, I'm not going to make any specific predictions on grade boundaries. Basically, I just think they're going to get, I think they should be around this kind of point. Someone said, when was that document made? It's literally just been released in the last few weeks that we've got here. And then someone was asking about degree apprenticeships. I think degree apprenticeships in these days have just become so much more like reputable and have like they're really great things. I think sometimes apprenticeships like a long time ago didn't necessarily have like the academic rigor, and I think these days they're really competitive. I think that they're like a great thing as well. I will do a stats live stream. I'll probably do one in a few weeks. Someone was asking about where can they get the aiming for A-star sessions. I've got too many screens and stuff going on here. If you go here, I've pasted the wrong thing in, doesn't matter. I'll put it in the chat or something, or maybe like someone who knows where you can buy those tickets for it. You can get those sessions. They're like 3 hours long and loads of stuff that you can do in that. Someone said, did I have more people joining last year or this year? The same question goes with your masterclasses. Definitely more people joining. Definitely more people have been joining all of my sessions and the live streams as well. I'm hoping to do a live stream next week. It is my birthday on Monday. So last year was the first live stream I ever did was on my birthday. So it's been a whole year of kind of getting started on live streams, and I'm hoping to kind of take live streams up a notch with this as well. Someone says, what's maths in Turkish? It's just mathematik, like kind of easy, really. What else have we got here? Oh, what's this? What routine habits can you do to maximize your chance of getting an A-star for maths? Practice, 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 practice. That's what you got to do. Just so much practice. Yeah, I'm a Taurus. I am a Taurus. Okay, what else we got? Thank you for my happy birthday wishes. It's like an early birthday wish. Maybe I'll jump on Monday and do that as well. Yeah, people keep saying like about me wearing glasses. I just have like, I've been out in the sun today. I get this like tan lines like on my face like immediately. I don't know, maybe it's because I'm like smiling too much and then I get too much sun here. But look at me, I'm getting so old. My face is getting all wrinkly. Don't know, I'll have to, next time I go to Turkey, I'll have to come back and I'll have had like the full like Turkish facelift or something as well. That's what people often go to Turkey for. And if I get too much more bald, one day you're going to see me with like a perfect hairline when I go and get my hair transplant in Turkey at some point as well. So yeah, I am planning on doing some A-level speed runs and stuff as well. I look more than a day over 20. I look a good 16 years over 20 is what I do. So yeah. Anyway, it's 2 minutes to 6. I am actually going to go out and have a nice bit of dinner tonight, which I'm looking forward to. And I've worked hard today. I've been doing all the preparation for the further mechanics session as well. I will try and do some further maths streams as well, because I know people really want that and there's less stuff out there for further maths. I just felt like doing something kind of easy today. Well, not easy, something that's easy for me as someone who does so much maths like this. So that's why I wanted to do some stuff on mechanics. I will put my annotated version of this in the Google Drive that's linked in the description. If you do want to come to any of the Aiming for A-star sessions, you've heard me say this tons and tons. You've just gone my channel homepage. They're actually it's like linked in the main part of the description as well. But I really enjoy doing these. It's just such a lovely community of people that are on this channel. I feel incredibly privileged to get to do this as my job. So I hope you all have a wonderful day. Hope you have a nice rest of your evening. It's basically the end of the day now. Maybe I'll do a tiny bit of revision or something. I don't know if you've got any chocolate left from Easter. I got some cheap Easter eggs at the supermarket, so probably going to make myself feel sick with all the chocolate I'll be eating later as well. But yeah, thank you so much, guys. Hope you have a really great evening. I will just be finishing this up right now. And someone says, do I miss my students from my videos? Yeah, those students in my videos, absolute legends. Sometimes they come along. They come along to these sessions as well, just to sort of say hi. Okay, guys, thank you so much, and some excellent people in the chat today, so really, really well done. Bye now. Have a good evening.